All right, guys, we are going to go over the guided practice from page 34. So it's a little confusing, and I want to make sure that you understand it, okay? So follow along with me. You should have already done page 34, and you should be checking your work. Okay, so Lee is sewing vests, and he has 16 green buttons, okay? And then Lee also has 24 blue buttons. Now, the key here is that all the vests have to be identical. So whatever number buttons you have to use the same number for all the vests. And they all have to have green and blue buttons. So we want to know how many vests Lee can make and what's the greatest number of vests Lee can make, okay? Well, if we know they all have to be equal, you have to come up with the numbers that are going to go into 16 and 24. And then we have to make sure it's the same number for both because it has to be equal. They have to have the same number of buttons and all the vests have to be the same. So if I use 15 buttons on one vest, which would be ridiculous, I can only use one on the other and that makes them not equal. I could use 2 buttons on each. 2 and 2 and 2 and 2. Okay. So here we go. So the first thing we want to do is we want to find out the greatest common factor. So what are the factors of 16? So the numbers that go into 16. 1, 2, 4. Let's make sure I don't miss any of them. 8 and 16. And then numbers that go into 24. 1, 2, 3, 4, 6, I know 8, 12, and 24. Now, we know that they have to have the same number. So I'm going to circle all the ones that are in common. So 1's in common, but even though I guess I'll circle it. 1 doesn't usually count. 2's in common, 4's in common, 8's in common. Okay, so the multiples are 1, 2, 4, and 8. And the greatest number of vests that Lee could make would be 8. Okay, and if this is confusing you, what I want you to do is actually draw out the vests. And you'll see that visual that'll help you understand why this is the greatest common multiple. Okay, so let's go on. This is the part that I really want to stress. So this is distributive property. Distributive property. And I know that when we look at distributive property, part of us says, why do I need to do this? And I promise you, you absolutely need this all through 8th grade. So it's really good that we're learning it now. And in 8th grade, you're going to be doing this with variables, which makes it a little bit different. So if we can learn it now with numbers and prove it to ourselves, that when distributive property comes back up again, it'll make more sense. So this is what it is. If I had 36 plus 45, okay, I first find the greatest common factor, which is 9. So instead of writing 36, I'm going to write 9 times a number. I'm going to keep my plus sign. And instead of writing 45, I'm going to put 9 times the number. Now we're going to use the little X's, but please remember we're not going to use them in later math, okay? So this is kind of just for the sake of what I'm showing you. So 9 times what is 36? 4. 9 times what is 45? 5. So this means the same. This means the same, and we still kept our plus sign. We haven't really changed anything crazy yet. This is distributive property. I get to take the 9 that's being multiplied in both of these and write it in front of some parentheses. It's really a times, but remember we don't need the times. Because when I write a number in front of parentheses, it means multiplication. And then I can add these 2 numbers. And it will give me the same answer, okay? If you don't believe me, try it. Try it. Do it right now, okay? So what you get to do, I'm going to erase this because I don't like the little X. You get to do 9 times 4. Keep your plus sign in between. And then 9 times 5. And this mean the same exact thing. That's distributive property. Okay, so if you didn't understand that, I want you to pause the video. I want you to do number 3 without me, and then start the video again and see the answer, okay? All right, hopefully you tried it. So I have 75 and 90. Their greatest common factor is 15. So I know I get to put 15 at the beginning of both of these. I kept my plus sign. That's really, really important. So what times 15 is 75? Oops. Sorry. 5. And what times 15 is 90? 6. So I can put my 15 in front, and I can put my 5 plus 6 in the middle. And distributive property, you're always going to see me do the little loops. 15 times 5, that's what this means. 75. Keep your plus sign in between. 15 times 6, 90. These mean the same thing. In the future, you're going to have to go from here to here instead of from here to here, kind of the backwards direction. So the better you understand this, the easier that part's going to be. Okay? And the last thing that you were supposed to do today is answer the essential question. So I am going to help you with that, and you can kind of check and see if your answer's in the ballpark, okay? The right ballpark. So the essential question is, let's write it. In case you have not done that, you need to write it. You need to know what you're learning and why you're learning it. So it says, how can you find and use. We can find stuff, but why do we get to use it? The greatest common factor of 2 whole numbers. Okay? So hopefully the way that you described finding the greatest common factor is that we take all the multiples of the 2 numbers, the 2 whole numbers, and we find the biggest number that goes into both of the numbers. Okay, so if it's 3 and 9, well, the common factors of 3 are 1 and 3, of 9 are 1, 3, and 9. This is the biggest number that goes into both of them. Okay, goes into it. Hopefully that terminology makes sense because I'll keep using it. And the reason that we might need this was kind of like the vest example. That kind of stuff happens where you have materials in front of you and you need to evenly be able to distribute things that you might have 2 different amounts of. You might be organizing, like work at a store one day and have to organize cards on a shelf. And you're going to have to come up with that number that makes sense to go across so that your displays are all even. You can't have 9 in one shelf and 4 in the next shelf. So you might need to come up with a common number that you can make all your shelves so that everything's kind of evenly distributed. Okay, so hopefully you came up with something like that. Think of other things. If you're still not getting it, I'm telling you, go to Khan Academy, K-H-A-N. I'll write that in case you've never heard of it, K-H-A-N. Look up GCF. Look up greatest common factor. You will find all sorts of good stuff, okay? And if you're still not getting it or you can't find something, let me know and I'll send you another video, okay? All right, good luck.